GCSE Physics boosters, and this video is about specific heat capacity. What's that then? Well, let's have a look. So now we talked about solids and liquids and gases. Now imagine in a solid, all the particles aren't just sat there, they've got kinetic energy. Because they're vibrating, they've got kinetic energy. Now they'll also have potential energy as well. I don't want to confuse you, but that would actually be negative because they're bound together. So not particularly bothered about that. Just think that they have kinetic energy because they are moving. Now, if each particle has kinetic energy, then the substance has what we call internal energy, and that is the sum of all of these kinetic energies. So something which is hot, like a hot cup of tea, has lots of internal energy because its particles have lots of kinetic energy. So internal energy is the sum of all the energies of the particles that make it up. Now, if we heat up something, like if we put it in a Bunsen flame or in an oven, then its particles are going to gain kinetic energy, and we say that its internal energy increases. If something cools down, like this bread just taken out of the oven, so it's losing heat energy to its surroundings, so its particles have less and less kinetic energy, we say its internal energy decreases. So if you heat something up, its internal energy increases. If it cools down, if it loses energy, then its internal energy decreases. Sounds very straightforward, but we've got to be clear on this. We have to be precise. Now, if a substance gains or loses enough energy, then it may change state, but that's the next video. We'll worry about changes of state in the next video. If the internal energy of a substance increases, then its temperature will increase. It will get hotter. Okay, this metal block has a thermometer in it measuring its temperature. If we give this block more energy, if we give it heat energy with this electric heater, its internal energy goes up and its temperature will go up. Temperature actually tells us, it gives us an idea of the average kinetic energy of the particles that make something up. That's basically what temperature is. Okay, and the more internal energy something has, then the hotter it will be, so its temperature will be bigger. This is an important experiment that you need to know. In this experiment, we're giving heat energy to a metal block using an electric heater. Because we have a voltmeter and ammeter there, we can work out how much heat energy we're giving it. And then we measure how much heat energy is needed to raise the temperature of the block. And that brings us to this quantity here, the specific heat capacity. And that's little c. In this equation, delta E is mc delta theta. Little c, that's the specific heat capacity. And that is the energy needed to raise the temperature of a kilogram by 1 degree centigrade. Okay, the specific heat capacity of a substance, like for example water or aluminium or copper or anything, is if you had a kilogram of it, how much energy would you need to raise its temperature by 1 degree? That's the specific heat capacity. Okay, in this equation, delta E is the change in internal energy. Delta means the change in. M is the mass in kilograms. C is the specific heat capacity, joules per kilogram degree centigrade. And delta theta is the change in temperature. Okay, who's that dude there? That's a new DJ. He's called MC delta theta. There you go. I don't know how he got in this video, but there he is, MC delta theta. Okay, here are some sums that maybe you want to have a go at first. basically using the equation delta E equals mc delta theta. For some of them, you're going to have to rearrange it. Pause the video, pen, paper, calculator. I'll show you my answers in 3, 2, 1, and there you go. In the first one, we're working out delta E. It says how much does the internal energy of the water change. In the second one, it's asking for the temperature rise, delta theta. So that's going to be delta E over mc. And in the last one, we're working out the specific heat capacity. So C is delta E over m theta.